Hello everybody and welcome to this tutorial on reverse Polish notation, otherwise known as postfix notation. In this video, I will explain what reverse Polish notation is. I will label the different elements that can be found within an equation. I will explain operator polarity, and I will also explain how to interpret reverse Polish notation. In this video, I will expect that you know the natural order of operations within a normal maths equation. It would also help if you are familiar with common maths operators that are used in relatively high-level code, i.e. those used in Python. So what is reverse Polish notation? Reverse Polish is an unambiguous way of writing a normal maths equation. It does not use any brackets, and it is very useful for allowing computers to easily interpret ordinary maths equations. So let's start with a very simple example. Here we have 1 plus 2. In reverse Polish, this would be written as 1, 2 plus. So in general, if we have A followed by some operator followed by B, where some operator is represented by this white square, which could be any operator, in reverse Polish, this would be A followed by B followed by the operator. So what we've done is we've moved the operator to the end of the equation. Hence, reverse Polish is sometimes called postfix notation. Now we know that equations can contain a lot more than just a single operator. So how then do we deal with equations that have many operators as well as functions? But first, before we can answer that question, we must know everything that a maths equation could contain. So if we have a normal maths equation like this one, which is written in infix notation, which you should be familiar with, we could write this in code as this, which we see below. So in this equation, there are many parts. First, we have the values. These simply represent the numbers within the equation. Next, we have the operators. These signify the work that should be done to the values within the equation. Next, we have functions. These are very similar to operators, except they refer to another external maths equation. And finally, we have brackets. These specify the order of operations when it is different from the natural order of operations. Now, it should be noted that there are two different types of operators within our equation. Firstly, we have binary operators. These are operators which operate on two different values. So for example, in our equation, we have 4 minus 3, and the minus symbol operates on both the 4 and the 3. Then we also have unary operators. These are operators which operate on just one value. In our equation, we have minus 5. The minus symbol only operates on the 5, so it is a unary operator. So what we could do is create a table which describes the operator polarity for many of the common operators that you would find in maths equations. So we have the binary operators on the left and the unary operators on the right. Now note that within this table there are some operators which are in both categories, meaning they can be both binary and unary. We must not confuse these operators when we do reverse Polish. What we can do is take the ambiguous operators, which can be both unary and binary, and create unambiguous versions of these. What I've simply done here is I've denoted the unary versions with the letter U, and I've denoted the binary versions with the letter B. So what we can do is we can take the equation from before and replace the ambiguous operators with unambiguous versions, giving us this. So what then would this look like in reverse Polish notation? So if we convert this equation to reverse Polish, we get this. Now, you would be forgiven for thinking this looks like a mess, as it's not easy to read. How then are we meant to read this? There are a few rules for reading reverse Polish notation. First, we start reading from the left side. If we come across a value, then we skip it. However, if we come across an operator or a function, then we must write it out using the previous values that we skipped over. So now, in our reverse Polish, we start reading from the left side. The first thing we come across is the value 5. Since this is a value, we must skip it. The next thing we come across is the unary minus operator. Since this is an operator, we must write it out. Now, unary minus requires one value. This means we must take one value from before the unary minus and write it out, which gives us -5. We then put this in brackets and insert it back into the reverse Polish. Now we repeat the process again using this new reverse Polish. The first thing we come across is the -5 in brackets. Note that things inside of brackets should be treated as normal values. So since this is a normal value, we should skip it. We then go to the 6, which is a value, so we skip it. Then 7, again we skip. And then we find a binary multiplication operator. Binary multiplication requires 2 values. So what this means is we take the 6 and the 7 that we skipped over previously and we write it out. So we have 6 multiplied by 7. We then insert that back into our reverse Polish. Starting the process again from the left, we read along until we reach the binary subtract, which requires 2 of the previous values, in this case the 4 and the 3. So then we write that out as 4 minus 3. Note that it is important to put the 4 first and the 3 second. So the first value comes first and the second value comes second. Otherwise, you would get 3 minus 4, which would be wrong. We then insert this back into the original reverse Polish. Then we start the process again and we skip along until we reach the division operator. The division operator requires 2 values. So we take the previous 2 values. Both of these values happen to be values that are in brackets, and we write that out. So we have 6 multiplied by 7 divided by 4 minus 3. We then insert this back into our reverse Polish. Starting again, the next operator we come across is the binary addition operator. So once again, we take the previous 2 values and write them out and insert it back into the reverse Polish. Now, reading from the left again, we skip the values and reach the floor function. Since floor requires 1 value, we must write it out using the previous value, which is pi, which gives us floor of pi. We then insert that into our reverse Polish. Again, we read from the left, and the first operator we come across is a binary addition operator. We write this out, giving us this. Since this is the last item in our list, it must be the final answer. So far, I have covered what reverse Polish is and how to interpret it by converting it into a normal maths equation. But how then do we convert a normal equation into reverse Polish? So how do we get the reverse Polish in the first place? We could use the Shunting Yard algorithm, but this algorithm is very complex, so I will cover this in another video. If you have made it this far into the video, please consider liking and subscribing and commenting your favourite pizza topping. Mine is pineapple. And with that, cheerio.